Hello everyone and welcome to a new discussion under this groundwater engineering course, and the new discussion today we are going to have about surface runoff. Earlier also in our discussion very briefly I touched about this, but before we go for surface runoff, I would like to discuss about these two terms which we have been we will be using in our discussion also, and the two terms are influent stream and effluent stream. Because names are so close that some may get confused, so that I thought that I will discuss first this one. Influent streams are those streams which contributes to water table. So, that means what I am trying to say, that the stream itself is recharging the groundwater, and effluent means that it is getting water from the water table. So, it is basically flowing the water table on the surface or water, because in the conditions where water table is shallow, whereas in influent streams where the water table is deep, it gets the water from streams. So, these streams are recharging. Another important point here I would like to mention, that the same stream at different stages in the flow may change influent to effluent or vice versa also. So, it depends again on slope conditions, geologic conditions, and of course, the discharge also. So, it is not necessary that a stream will always be influent throughout its length or effluent throughout its length, not at all. Another thing which you can see, that in the top part it writes the stream loses water basically. So, the flow towards the water table, this is how you can remember the flow towards the water table, which is influent, and effluent, the stream gains water. So, that means water table is supplying water. So, effluent, like effluents flowing, so we normally say in case of pollutions. So, the stream or a reach of a stream is more important, because a stream can change from effluent to influent at any stage of its length. So, a stream or a reach of a stream that loses water to the ground and contributes to the water to the saturated zone is known as influent, as this one. And whereas the stream which fed directly by groundwater piezometric surface and is above the base level, base of the stream is known as effluent. So, here this stream is above, the water table is above, and therefore, this water table can supply water to the stream. So, effluent or gaining stream, you can also remember in this way, the losing stream and gaining stream. So, losing to the groundwater, gaining from the groundwater. Okay, now come back to our announced discussion on surface runoff. If we recall the hydrologic cycle or water cycle, there when precipitation occurs, there will be interception if the vegetation cover is there or some structures are there. Then some water will flow on, some water may infiltrate, percolate to the water table as shown here. It is not continuous, there are two arrows are there. So, the first part is the infiltration, second part is the percolation. In subsurface condition, depending on slope, there might be a through flow, but the large part of water, again depending on the conditions, soil and rock conditions, slope conditions, there will be overland flow, and this flow which we are talking is surface runoff. So, runoff in case of a stream flow is the water discharged through the streams consisting wholly or in part of water contributed by overland flow. So, this overland flow water will ultimately end up in a stream, and this stream here in this example is shown as effluent stream. That means, it is getting water from the water table. So, it is also getting water from, because of base flow, the water is also coming, and of course, the surface runoff will also contribute. So, overland flow or surface runoff, and also the stream gets water from groundwater as well. So, now if as I have mentioned that depending on slope conditions and geologic conditions or rock types, soil. So, if we are having a relatively impervious horizon occur above the water table, like here in this example water table is here, and if we are having a horizon or rock which is relatively impervious, and then the water table outcrop at the land surface which is here, water may flow over them to each stream as interflow. So, interflow can also occur in such situations. Further, runoff will depend on many factors, few factors I have just discussed. So, let us see one by one. Dimensions and configurations of the drainage basin. This is another very important thing. Even the shape of a catchment or basin influences the surface runoff, and the material which are present on the surface and the interceptions things which are also there. So, further climatic conditions including intensity, duration, aerial distribution of precipitation. Nowadays, as we are observing that the intensity of rainfall is increasing because of people attribute to the climate change. Duration has reduced and aerial distribution of precipitation is may not be as extensive as in the past. So, what I am trying to say, the spatial distribution of precipitation is also changing, and what it is contributing? It is contributing more surface runoff, because intensity is high, duration is less. So, more water available, but less water, not sufficient water can go to underground. So, most of the water is flowing on the surface. So, more surface runoff means more flooding, more chaos. Third point which influences the runoff depends on moisture content of soil. If soils are already moist, having the moisture in there, high moisture content, and then precipitation comes again, then runoff would be more. But initially when soils are like just before the monsoon, the soils are dry normally, soils or whatever the surface available, and if rain occurs, then there will be less surface runoff. Topography and land surface slopes, because gradient is important. So, in earlier discussion also in case of permeability, hydraulic conductivity, this is what we have been discussing. So, the topography and land surface slopes also influences the surface runoff. So, continue with this, that the fifth influencing factor on surface runoff is infiltration and permeability characteristics of soils and subsurface formations. During this course, in earlier discussions, once I told you that if you visit a desert area like when I was visiting this Jaisalmer area, and for 10 or 20 or tens of kilometers, I did not find any culvert and bridge. Then it came in my mind why there is no culvert or bridges which road is crossing. The reason is the infiltration and permeability is very high, and that does not allow water to flow as a surface runoff, and therefore, there is no development of drainage. So, these two infiltration and permeability characteristics of soil and subsurface formations also there. So, soil may be thick, but if subsurface material is also permeable and which can allow water to percolate, it is again it will influence the surface runoff. Now, what is the relationship with the aquifer stream relationship? That means effluent and influent, whether the river is contributing to the groundwater or groundwater is contributing to river. This is what the river stream relationship. And human activities nowadays, large part of the land is having some sort of human activity all the time, whether it is being used for agriculture or for urbanization or for industries, roads, bridges, all kinds of things. So, human activities also influences the surface runoff. We sometimes divert the drainage from one place to another, and that is also creates problem. Diversion of water influences. Another factor which I have just touched about, which influences surface runoff to large extent, that is the climate. which influences, and which we have discussed that if intensity of precipitation or rainfall is high, duration is less, there are more chances of surface runoff. In arid climate, the example I gave about the Jaisalmer, with the low precipitation, high evaporation, runoff will be low, but also because of high infiltration, high permeability, because you are having loose sand, again there will be, it will also have the surface, less surface runoff, or basically no surface runoff, no development of any surface drainage. It will be high in humid climates with high rainfall. Why high? Because the soil moisture is high, and therefore it will increase the surface runoff with high rainfall. And low intensity of rainfall increases infiltration. As people say that rain precipitation which is occurring if very slow, then it is always good from groundwater point of view, or even soil erosion point of view. So, it increases the infiltration and evaporation losses and reduces the surface runoff, and therefore, the net effect would be less surface runoff. Meteorological factors like type of precipitation, rain, snow, sleet, etc. Snow generally does not flow like water in case of rain, but ultimately it melts and can flow. Rainfall intensity is there, which we have already discussed. Rainfall amount, how much water is how much water is falling. Rainfall duration, that is also important. And nowadays we hear a lot about cloud bursts. What basically, briefly if I say, cloud bursts are nothing but a intense rain in a local area, a small area, in a short duration. But the intensity of rain and the amount of water it is pouring from heaven is so high that it causes the flood, and it damages or wiped out if there is a village or forest or anything. So, distribution rain over the drainage basin also influences surface runoff, and direction of storm movement from where the things are moving, and precipitation that occurred earlier and resulting soil moisture. That I have said that initially when pre-monsoon, the soil may not be from top to some say a few feet, may not have much moisture. So, the first rain will always be more absorbed, less surface runoff. But once the soil becomes having sufficient moisture or saturated with water, so then next rain, that means more surface runoff. So, other meteorological and climatic conditions that affect the evaporation, such evapotranspiration means vegetation cover, of course, the temperature, wind can also play a very important role, because it changes the your moisture conditions of the surface. Another parameters, physical characteristics which are also affecting runoff, that is the land use. How land is being used, what is the cover over the land, whether it is forest cover, whether it is agricultural land, whether there is urban land, built up land, that kind of thing. So, generally in built up land, you do not have much place that water can go downward. So, it flows as a surface runoff. So, 99% of water is gone as a surface runoff. And from groundwater point of view or groundwater recharge point of view, I always say it is a wastage. So, the important water which has come through rain, through precipitation, especially in Indian system, the monsoon, and then 99% water has gone as a waste, no use. So, that is why artificial recharge structures and other things are created, especially in urban areas, to increase that, to reduce the surface runoff and increase the groundwater recharge. Vegetation cover influences definitely. If a barren land is there, then there will be more surface runoff. If there is a vegetation, that will create the interference with the flow, and of course, it will allow more infiltration, more groundwater recharge. Soil type also depends. If it is clayey soil, then there is a chances of more surface runoff, but if it is sandy soil, loamy soil, it will have less surface runoff. Drainage area, what is the shape of drainage, and what kind of rocks are there, what kind of land cover is there, land use is there, that also influences. Basin shape, that also influences surface runoff. Even the flooding. So, if I give you an example of that, I am having a basin, though I am just drawing like this. So, outlet of this one is here, and this is the drainage is there, and this all drainage is coming at the center like this, and maybe finally it is coming like this. So, if we are having this kind of a scenario, that means a shape of a drainage basin is rounded, there are more chances of flooding, because all these streams will bring water almost at the same time in the center. Whereas a longitudinal or a elongated drainage may not have chances of flooding. So, assume that uniform rainfall occurs, then the first water will come out from this, then this, and finally from the top of the basin. So, the basin shape also influences surface runoff and also influences is a related thing, which is flood. Elevation also play very important role. Elevation influences your gradient or slope, and that too is if slope is high, there are more chances of surface runoff. If slope is less, there are less chances of surface. So, hindrances, if we are thinking from infiltration, percolation or groundwater recharge point of view, then hindrances should be created, so that water does not flow even in case of high slopes, if that is there. If you see that in hilly terrains, like if I give example of Himalayan terrain, there are terrace farmings. Agricultural lands are there are terraces, series of terraces. Sometimes if you see the entire slope, you may find there are more than 100 terraces in one slope. So, they will reduce the surface runoff like anything, because first if there is a rainfall, the first water will come on the top, some part will be absorbed, then it will be surface runoff, next likewise. So, the slope has been hindrances in the slope has been created through this terrace farming, and that because in such regions you do not have much chances of irrigation. So, all crops basically depends on the rain and or whatever the precipitation occurs, and therefore, these terraces are in that way reducing the surface runoff, and of course, they are reducing the soil erosion. And the slope of the land, which I just was mentioning, that if topography can be disturbed by human interventions through these terrace farmings, then we can have a better control over surface runoff. Drainage network patterns also influences drainage network pattern. I have shown these with the two diagrams, and ponds, lakes, reservoirs, sinks and the basins with the prevent or delay runoff from continuing downstream. So, in case of groundwater recharge, this is what we recommend all the time, that if we can delay surface runoff by few hours, weeks or months, definitely some of the water will go downward. Of course, there will be surface evaporation from surface of water body, but does not matter, we will still get lot of water through infiltration, percolation to the water table or a saturated zone. So, these are, you can say, the hindrances or storages of on a surface to reduce the surface runoff, and reducing surface runoff means we are getting direct benefits not only from groundwater recharge point of view, but also from your soil erosion point of view. Further, surface runoff in permeable layers reduce the runoff by allowing rapid infiltration of precipitated water to subsurface, and high permeable rocks will hopefully, if they are exposed on the surface, will have less surface runoff, and permeable layers while reducing surface runoff increase groundwater runoff. So, this is what we want, groundwater. The water should flow in the subsurface condition. That means it is getting saturated, it is recharging groundwater regime or groundwater aquifer. and vegetation causes a decrease in the rate of runoff by absorbing more rainwater and obstructing flow. Vegetation play a double role here in sense that when the raindrop comes from sky, first it is intercepted by the leaves and it reduces the speed or velocity of your raindrop, and then it falls, might be later 1 second or 10 seconds later, and then it is not falling from big height. So, therefore, it will be, there are more chances of absorption, there are more chances of less surface runoff. So, that is why vegetation, and even on the surface runoff or overland flow, if vegetation is there, then surface runoff is going to be less. So, vegetation anyway is providing benefits from two different mechanisms. One is it is reducing the intensity or velocity of the rain, and secondly it is also reducing the surface runoff or decreasing the rate of surface runoff. Human activities, construction of reservoir, afforestation, deforestation, urbanization, irrigation also induces runoff pattern depending what kind of structures we are. Now, there are two more points are here in this discussion. One is infiltration, excess overland flow, and another one where it is not like this. So, we will discuss one by one that this occurs when the rate of rainfall on a surface exceed at which water can infiltrate the ground, and any depression storage has already been filled. So, that means infiltration is exceeding the overland flow, that is always good, and whereas overland flow exceeding infiltration is a reverse scenario. So, this is called flooding excess overland flow, and Horton gave a formula. So, that is called Hortonian overland flow or unsaturated overland flow. More commonly occurs in arid and semi-arid regions because of high permeability, dry sand, less soil, mostly sand, and like in desert areas where rainfall intensities are high and the soil infiltration capacity is reduced because of surface sealing, or paved areas. There might be some paved areas in case of urban areas, and also occurs largely in the city areas where pavements and prevent water from infiltrating. Now, saturation excess overland flow. When the soil is saturated and the depression storage filled and the rain continues to fall, the rainfall will immediately produce surface runoff. So, this happens in the later part of monsoon season in this country, that initially soils are dry, they absorb lot of water, but once they are saturated top part, then the percolation may be going on, but more surface runoff will occur if more rainfall occurs. And the level of antecedent soil moisture, the already soil it is there, antecedent means here, is one factor affecting the time until soil becomes saturated. And runoff is called saturation excess overland flow. When your surface is full of saturation moisture, then overland flow occurs. So, saturated overland flow or also done runoff is called. Now, we have touched this part. So, let us see that what is basically antecedent soil moisture, that after water infiltrates the soil as on upslope portion of the hill, the water may flow laterally through the soil and exfiltrate, flow out of the soil close to the channel. So, that is what is called subsurface return flow or through flow, which we have seen earlier in a diagram, that through flow occurs along the slope, but not on the surface, and it flows, the amount of runoff may be reduced by a number of possible ways. So, this through flow is also obstructed or influencing factors are there, like a small portion of it may get evapotranspire because of vegetation might be there and root zone is there, water may become temporarily stored in micrographic depressions, small depressions, and portions of it may infiltrate as it flows over land. So, a lot of things are happening once the precipitation occurs, and depending on topographic conditions, slopes, geology, land cover, these surface runoff will get influenced. So, any remaining surface water basically eventually flows into receiving water body such as river, lakes and estuary, oceans, depending where this is located and where rain is occurring. Now, subsurface return flow, that is the soil which is saturated and the depression storage filled, the rain continues to fall, the rainfall will immediately produce surface runoff, and in the level of antecedent soil moisture is okay. So, surface runoff occurs when the soil becomes fully saturated, and we have been discussing the rainfall intensity exceeds the infiltration rate. All the condition being similar, the runoff is proportional to the catchment size. That is another important thing, that larger the catchment will produce more the surface runoff, smaller the catchment will produce less. So, law of mass conservation, inflow equal to outflow plus minus changes in storage. We have discussed this part in water balancing also. So, inflow would be equal to outflow plus minus changes in storage. So, what from groundwater recharge point of view, this is should be our focus, that we should change by some means change in storage, that too in terms of positive changes in storage. So, if that we can do, that will recharge the groundwater regime in a much better manner. So, the stormwater runoff be a problem, and so water flows over the land surface, stormwater picks up potential pollutant that may include sediment, nutrients and fertilizers, bacteria from agricultural fields like chemicals, metals from rooftops and roadways, and petroleum products from leaking vehicles. All this will go in water, in flood water. That is why flood water is not safe and it is not safe for any kind of consumption, because the many things are getting mixed with their water. So, why storm water runoff be a problem? Because of these pollutants which is originating from a large land and are without a single point origin, otherwise it could have been treated. And in contrast, point source pollution originates from a single point and these can be treated. So, polluted storm water runoff can be harmful to plants, animals and people also. So, runoff model, if we want to do that kind of modeling, then mathematical model describing the runoff rainfall relationship of a rainfall catchment area and drainage basin and watershed. So, more precisely it produces the surface runoff hydrograph in response to rainfall event represented by input as a hydrograph. So, in other words, the model calculates the conversion of rainfall into runoff or discharge. Sometime people, if we are talking about stream only, then discharge. So, it is the what the model does will convert the rainfall into your discharge. So, now we are coming to end of this discussion on surface runoff. So, lots of free open sources are available for modeling, softwares especially I am talking, if somebody is looking for that. So, top 12 best open sources software in water resources are available from this link, and water resources surface softwares are available from this link for further deep going into modeling part of surface runoff. So, with this I thank you all for listening. Thank you very much.